Now this is an orifice. It's just a little hole, and the water is going to go through this hole, and because you have a higher velocity, you're going to have a lower head just from going through. Here is the orifice meter. The orifice is located right here in the middle of the pipe. There's flanges on each side that holds it together. So it takes one of these discs and it just holds it in there. The water comes in from this direction and have a garden hose connected here, goes through and out the end. So someone could measure the amount of water that comes out the end just with a graduate cylinder or any kind of volumetric container and measure that over time. And what we have here is we have a line connected to the pipe before the orifice and a line connected to the pipe after the orifice. Water will go up this line, and depending on what kind of a head you have here, it will go up really high if it's a high head, and it won't go up too high if it's a low head. So when you have a lower velocity going into the orifice, it's going to go up high. And when you have a higher velocity here after the orifice, it's going to be low. And what we want to know is what is the difference in height between here and here. Now it might go up to about 10 feet or so. So what I did is I connect these tubes to a pole like this. Okay. Someone will have to hold this thing. And while the flow is going through there, you would look up the pole and you see how far up the water went. And that's the delta H. Someone else is measuring the flow rate, so you have a delta H versus Q data. And what we want to do is we want to conduct a number of experiments with different flow rates and therefore different delta H's for two kinds of orifices. We have the big orifice here and the smaller orifices in there. The way you'd vary the flow going through is the tap inside and possibly this valve here. But we just have to play around with it to see, what functions mostly. Like I said, the main thing is to make sure that the water that's going up the pipe from here, from the beginning, doesn't just spill over on the top. Okay, I have some flow going and obviously some assistance, and I told you need many hands for this. You have to adjust the flow in the inside, where the mixer is, until you finally get a flow where it's not coming off the top. So this pole is extended up about 10 feet or so. Then you have to have someone taking the measurement. So what we have here is a graduate cylinder, and they're just going to let it fill the graduate cylinder, and over time, and that's the flow rate. And then when I look at the water height, I can see that on here, it's right there where I'm touching it with a, I'm not sure if it's in the frame, but it's right there. And then the other side has to be down somewhere right here, right there. Okay, so then actually all I want to measure is the delta H. So if I put the tape measure here on the top of that, and I come down here and I see a delta H of 52. So I have 52 inches and at a certain flow rate. And then I have to make another adjustment, go in there and change the flow rate, so you have your assistant that you don't like standing right underneath here so he can get wet. You let it. Okay? The idea is to collect as many flow variations as you can and delta H variations. So you just have to keep on fooling with that. Now, this time the orifice is this little teeny weeny pinhole. So some groups will be doing a little teeny pinhole, and other people are going to be doing a larger size orifice. So we have two different orifices, and we want to get a variation in flow with a variation in delta H.